Welcome to Partial Fractions Case 2, Denominator with a repeated factor. This is the sequel to Case 1. Here we've got an expression, an algebraic fraction, and we've got a distinct factor x plus 1, but now we've got this repeated factor. So this needs dealing with in a different way. And what I want you to do is write down what you think how we could express this thing on the left as partial fractions. Have a go. So what I wanted really was just you to start it off. So what would we do? We would let x over x plus 1, x plus 2 squared be identical to a over x plus 1. I'm definitely going to need that distinct factor, plus b over x plus 2 squared. I'm definitely going to need this. There's no way that I could add them together to give an x plus 2 squared on the left-hand side without it. Did you go for this secret term here? Because that is the new bit that we need. Basically, the x plus 2 squared will give us two terms that we need to deal with. Because if I have something like a over x plus b over x squared, then this would become ax over x squared plus b over x squared. And we see that this 1 over x, it changes the top coefficients. Well, it causes when we add them that we have to sort of manipulate it a bit, but we're left with x squared on the bottom. So this doesn't actually change the denominator. Same sort of thing happens with this x plus 2. I'm just trying to give you reasoning behind it. Okay, so just to, I've got one I made earlier here. This is the sort of thing we're going to do, and this form needs to be used for similar cases. Whenever you've got a repeated root, as long as it's a squared, you might want to think, what do I do if the x plus 1 is also squared? Or what if one of them was cubed? But I'll let you ponder that. Okay, so we've let this equal this, and now we're going to try and work out A, B, and C. You might want to have a go at it yourself, or you might just want to watch along and make notes on it, but do think about it as I talk through it. All right, so we've started us off. So the next thing we're going to do is we're going to multiply through by the denominator to get rid of it. So x is going to be identical to a x plus 2 squared plus b x plus 1 x plus 2 plus c x plus 1. Note how multiplying it causes this. I'm not going to go into any more detail on that. Now we're back where we were, except we've got three unknowns, a bit like when we had three distinct factors. How are we going to deal with this? It's very similar, but actually there's a little interesting thing happening because I've got an x plus 2 here and an x plus 2 here. So I can let x equal minus 2, and that's going to mean that minus 2 is equal, the a is going to cancel, the b is going to cancel, I'm just going to have c minus 2 plus 1. That's going to be minus 1, so minus 2 is equal to minus c, and c is going to equal 2. I found my first coefficient. What next? Let x equal minus 1. Because now the b's and the c's are going to cancel, and I'm going to get that minus 1 equals a minus 1 plus 2 squared. This is just 1, so I can ignore it, and I can write that a is equal to minus 1. Brilliant. Okay, how about now? When we had three distinct factors, we now did another substitution for x to kind of get rid of one of the terms, but here we can't. I've dealt with the ones that get rid of, one of them got rid of b and c, and one of them got rid of a and b. So how are we going to deal with it? Well, we can still do a substitution. We can just pick another number that kind of makes life a little bit easier. So how about we let x equal 0? Then I'd get that 0 is equal to a times 2 squared plus b, because all I've done is put 0 into here, b times 2 plus c times 1. Yeah, I've just replaced all these x's by 0 and then sort of followed through on that. So 0 is going to equal 4 lots of a, that's minus 4 because I know what a is, plus 2b plus 2. So this is going to give me minus 2, so then I'm going to get that 2 is equal to 2b, and I've got that b is equal to 1. Now I've written that in green, and that is actually method 1, substitution. Method 2, actually I should probably just write method 1 here, sorry. Method 1 from this point on. Method 2 from this point on. Let's come back to comparing the coefficients. Now you might think, hello, you really want to compare coefficients when you've got to multiply out all these brackets? I don't need to do that. I'm just going to look at the coefficient for x squared. Now if I look at the coefficient for x squared on the left hand side, then it's 0. If I look at the coefficients on the right hand side, well, over here I'm going to get ax squared, so my coefficient is just a. Here I'm going to get x times x squared, so I'm going to get plus b. And then I'm not going to get one for c because there is no x squared, so I can simply write down that b is equal to minus a, and I get that b is equal to 1. Now I think this is a little bit easier than doing the substitution for x equals 0. Up to you, but be aware this is where the power of comparing coefficients can come in. So I strongly advise that you do understand and learn that method and even use it. Okay, we're basically there then. Whoops, that is not meant to happen. We're basically there. Just need to write down my final answer, and I'm just creating space. Okay, so overall we can write down that, so therefore I think I'm going to come back to work writing in red. Therefore x over x plus 1 x plus 2 squared is identical to a, which is minus 1, so minus 1 over x plus 1, plus b, which is 1, x plus 2, and then c was equal to 2, so it's going to be plus 2 over x plus 2 squared. And we've done our first partial separating algebraic fraction with repeated factors into partial fractions. Now, just very quickly, I suppose one thing is, why on earth would we want to do this? It kind of makes sense sometimes to be able to add fractions together to get the left-hand side. Why separate it out? Why are we interested in going that way? Well, I'm not going to tell you at the moment, but I just want you to maybe think about it. What purpose could that have? And you can message me if you want, but I don't want to give it away. It's something we'll come on to later in the course. Let's look at a second example. Okay, how are we going to deal with this? Again, you might be confident and just be willing to give it a go. Otherwise, I'm going to go through it. Let x squared plus x minus 1 over x squared x minus 1 be identical to a over x squared. But now I'm going to have this cheeky little term here, plus b over x plus c over x minus 1. All right, let's go. This is going to implies that x squared plus x minus 1 will be identical to a x minus 1 plus b x minus 1 plus c x squared. Good stuff. What should we do? Let's let x equal 1 first. Then we're going to get that 1 plus 1 minus 1, that's just 1, is going to equal, a is going to disappear, b is going to disappear, c times 1 squared, we just get that c is equal to 1. Let x equals 0, that's going to mean that minus 1 is equal to minus a, because b and c are going to disappear. When I put 0 into here, I'm just going to get minus 1, so I'm going to get minus a, and that's going to mean that a is also equal to 1. Brilliant. What now? Well, we could do another substitution, but we can't use 0 because we've already used that. So you'd maybe have to use 2 or minus 1 or something like that, and then substitute in a and c like we did before. No. Let's compare coefficients. That's just going to be quicker. Coefficients for x squared. Sorry, let me do that again. X squared. If we look at the right hand side, then we get 1 because I've just got this x squared by itself. Okay, we're not going to get any coefficient from the a. We're going to get a b x squared here. So we're going to get that 1 is equal to b. And then we're going to add that to c, okay, because I've got this term here. All right, brilliant. So we know what c is. We get that 1 is equal to b plus 1. And therefore b is equal to 0. Okay, do not adjust your screens. This did just happen. It can be, in fact, that this term is 0. So we always have to include it, but b could be 0. A and c are never going to be 0. That wouldn't make any sense for this fraction to exist, but b can be. So actually we've done it. Therefore, x squared plus x minus 1 all over x squared x minus 1 is identical to 1 over x squared. I've just substituted my a into there. No need to put this term in, it's gone. And I've got my c, which is also 1, so it's plus 1 over x minus 1. And in this case, we just get these two partial fractions coming out. All right, this last one is definitely a try it yourself first. So pause the video, have a go. I'm going to go through it. Like if you try it and then just skip to the end of this video, you can check your answer and you can be confident. Otherwise, it's just another one. It's just slightly more awkward because I've got a 2x plus 3 in there, but it's the same idea. Right, I'm going to go through it. So let 3x squared, and also it's a bit more awkward because I've got 3 terms on the top. Let 3x squared plus 6x plus 2 over 2x plus 3 x plus 1 squared be identical to a over 2x plus 3 plus b over x plus 1 squared plus c over x plus 1. I would like to see this sort of thing in your working. Don't just rush into it. I know that took far too long to write out, but please be careful and rigorous. 3x squared plus 6x plus 2 is going to be identical to a x plus 1 squared when I multiply through plus b 2x plus 3 plus c, that was meant to be a c 2x plus 3 x plus 1. Hopefully you can fit it all on your page. Alright, let the substitution begin. What should we do first? Let's do the easiest one. Let x equal minus 1. Then I'm going to get 3 minus 6 plus 2 is equal. The a is going to disappear. The c is going to disappear. I'm just going to get b minus 2 plus 3. 3 plus 2 is 5, minus 6 is minus 1, so I've got minus 1 is equal to b, and we've got our first one. Brilliant. Now let's x equal, I need to make this 2x plus 3 equal to 0, so let x equal minus 3 over 2. Okay, this is where it just gets a bit more horrible, and we probably want to get our calculator to help us out. You can do it by hand, but let's be careful. So 3 brackets. I'm now going to write it as minus 1.5 to avoid using the fraction button. And then I'm squaring that. I'm going to do plus 6 times minus 1.5 plus 2 equals minus 1/4. Minus 1/4. And that is going to equal, like I said, the b and the c are going to disappear, so I'm left with a minus 1.5 plus 1 squared. And minus 1/4 is going to equal, sorry, that's meant to be a 4. It's going to equal a, and then it's going to be minus 0.5 squared. That is just 1/4 actually, if you work that out. So I've got minus 1/4 equals a times 1/4, and therefore a is going to equal minus 1. Oh, bit of effort to do that one, but there we go. I think I'm going to delete this just so I've got enough space. Okay, bring it up. Right, last little bit, let's compare coefficients. Always a good method for this at this stage. Coefficient, again, of x squared means I'm going to get that 3 is equal to, so I'm going to get an x squared when I multiply this out, so 3 is going to equal a. When I multiply b out, I'm not going to get any coefficient for x squared. When I multiply c out, I've got 2x times x. That's going to give me 2x squared. So it's going to be 2cx squared. So I'm going to add on plus 2c. Therefore, 3 equals minus 1 plus 2c. 2c equals 4. And therefore, c is equal to 2. Brilliant. We're basically there. So finally, actually, I'm just going to write that over here, just leave me enough space. Therefore, 3x squared plus 6x plus 2 all over 2x plus 3 x plus 1 squared is identical to minus 1 over 2x plus 3. b is minus 1 as well, so minus 1 over x plus 1 squared plus 2 over x plus 1. And we've managed another partial fractions question. Yeah, I know there's a bit involved, isn't there? But it's the same kind of method every time. Please practice it. Make sure you're happy. And I'm going to put a few challenge questions in there to look at extra repeated roots. But that is it. Well done.